right, next we have complementary and supplementary angles. So I think we've talked about these before, but complementary angles are two angles whose measures have a sum of 90 degrees. So they're measured, the angles add up to 90 degrees, right? And there's two of them, so it's always a pair. So they can be adjacent, like you see in this situation, or the non-adjacent here. So kind of just depends, and they can, but either way, if they are complementary angles, they'll form a right angle, right? When you put them next to each other. Okay. All right. So those are complementary angles. So supplementary angles are two angles whose measures have a sum of 180 degrees. So once again, they can be adjacent, they can be non-adjacent, but either way, they add up to 180. And so if you put them next to each other and they add up to 180, then they're the sides that they don't share, right? If they're adjacent and they are supplementary, I should say, the sides that they don't share are opposite rays, right? That's one way you can think of it. And they form a straight line. And with complementary and supplementary angles, if you know one, you can find the other, right? So with complementary angles, if you know, so angle A plus angle B would have to add up to 90. So if I know A, I can find, or if I know B, I should say, I can find A by doing 90 minus B, right? The same thing the other way around. B would be 90 minus A. So same thing with supplementary angles. The angles two angles add up to 180, right? So if I know B, I can find A by subtracting from 180, and the same thing, if I know A, I can do 180 minus A, and that'll tell me B. All right, so next we have a linear pair, and that should look familiar because a linear pair is a pair of adjacent angles whose non-common sides are opposite rays, right? We just talked about that. That's what happens when you have two supplementary angles who are adjacent, right? So linear pairs are both adjacent and supplementary, right? So not only are they adjacent, but they're supplementary, which means that their non-common sides are opposite rays. So they form a straight line, which is 180 degrees, right? Okay, so you could have a situation where you have two angles, like angle 1 and angle 2, that are non-congruent and a linear pair. So you can still, if you know one, you can do 180 minus that one to find the other. Here's a situation where you have two congruent angles that form a linear pair. Okay, and then here's another situation of a linear pair. All right, now an angle bisector. An angle bisector is a ray that divides an angle into two congruent angles. So here on this first image, we have ray KM that divides angle LKJ into two congruent angles, right? This is a construction. We might have some time later on in the semester to explore construction. So this is an angle bisector that's actually constructed using a compass and a straight edge. All right, and then here's another one that gives you kind of a clear image of two congruent angles formed by this angle bisector. All right, so an angle bisector is a ray that divides an angle into two congruent angles, right? Just like a segment bisector is divides a segment into two congruent segments.